In this video, we will be solving January 2025 Maths A Level P2. In question 1, we are given an arithmetic series S that goes 2 plus 5 plus 8 plus 11 plus so on plus 254, and we need to find the number of terms in the series. In this question, we will use the equation UN equals to A plus n minus 1 times D. This is given in the formula sheet, so no need to memorize this. Now, UN is the value of the nth term. So in this case, because we want to find the number of terms, this is the last term. So in this case, this would be n. So UN in this case is 254. The A is always the starting number. So in this case, A is 2 plus n minus 1, because n is the term that we want to find, because we want to find the number of terms in the series. And D is the difference between each term. So in this case, it's 3. 5 minus 2 is 3. 8 minus 5 is 3. So in this case, D is 3. If we go ahead and take the 2 to the other side, it becomes 252 equals to n minus 1 times 3. If we get rid of the 3 and divide it on both sides, we'll be left with 84 equals to n minus 1. And leaving n by itself, we get n is equals to 84 plus 1, which is 85. In part B, we need to find the sum of the series. Now, the sum of the series, since automatically in the question it says the sum of the series, we know we need to use the equation Sn equals to half of n plus times A plus L. So there are two sum equations. One is this one, and the other is Sn equals to half n times 2a plus n minus 1d. But since the L here stands for the last term, and in this case we are given the last term, this one will be much easier to use. So we'll be using that one instead of this one. But the other one could also be used. So if we go ahead and just substitute the numbers, we get half times n. We found the number of terms to be 85 previously. And A plus L is 2 plus 256. And solving this, we get 10,880. Question 2 says, find the first 4 terms in ascending power of x of the binomial expansion of 2 minus 5x all to the power of 8, giving each term in simplest form. This is a standard question. You will be asked this very often. In this case, we will need to do the choose method, where you say for the first term 8, choose 8 times the first number to the power of 8, so all of the powers. Then you'll say plus, and then the second term you will do 8, choose 1. Then you will multiply it by the first term again, but to 1 power less than the previous one. So in this case, 8 minus 1 is 7. And also you will multiply it once more by the final term here, which is minus 5x n to the power of 1. Then you will add it again, and you'll do 8, choose 2 this time. Again, 1 power less, so 2 to the power of 6, and minus 5x to the power of 2 this time. And for the final term, you will do 8, choose 3, 2 to the power of 5, times minus 5x to the power of 3. You will add all that up. So the first term will be 256 plus, so this together is 1024 times minus 5 gives us minus 5120, and the x is to the power of 1, so it remains x. Then you go on to the other one, next term. In this case, this is 1792 times by minus 5 squared. So we times it by 25. We get 44,800 x squared in this case. And if we go ahead and do the final one, we do 8 choose 3 times 2 to the power of 5, which is again 1792, but only this, and we multiply that by minus 5 cubed. We get minus 224,000 x cubed in this case, and that is the first 4 terms in ascending power of x, giving each term in its simplest form. In part B, it says that this expansion was used to find an approximation for 2.05 to the power of 8, and we need to find the value of x that should be used for this to be valid. Since the powers are equal, we can just set the bracket to be equal to 2.05. Rearranging that, we get minus 0.05 equals to 5x, and x equals to minus 0.05 divided by 5, which is minus 0.01. In question 3, we are shown an open-topped container used for holding water. The container is in the shape of a cuboid and is made of sheet metal. The base of the container is a rectangle 3x meters by x meters, and the height of the container is y meters as shown in figure 1. Given that the capacity of the container is 120 meters cubed, show that the area, meters squared, of the sheet metal used to make the container is given by the equation A equals to px squared plus q over x, where p and q are positive constants to be found. So first of all, how try to find this equation. First, we will use all the information that is given to us. So we know that the volume, the capacity, which is the volume, is 120 meters cubed. And the volume is just base times width times height. So we can just say that quickly. So 3x times x times y is equal to 120 meters cubed. So if we take a look at the equation below again quickly, we realize that we need to show that without the value of y. So what will we do? We will leave the y on the left side by itself, rearranging the whole equation. And this will give us y equals to 120 over 3x squared. Simplifying that, we get y is equal to 40 over x squared. Now we need to show that the total area of the sheet of metal, so the surface area of the cuboid, is given by that equation. So what we need to take into account is that this is an open-top container, so the top part we will not include in the equation. So we'll have 2 of these sides, one here, one there. 2 of these sides, one here, one there. And one this side here. So knowing that, we can just add all those sides and we will find that equation. So we said before 2 of these sides, which is 2 times x times y. Then we add another 2 of these sides here, which is 3x times by y. So 2 times 3x times y. And finally, only 1 of this side, which is 3x times x. Now, because we need to show this equation without y, we will go ahead and substitute the y for this that we found here. So we'll say 2x times 40 over x squared plus 6x times 40 over x squared plus 3x squared is equal to a. Cancelling this out, we're left with 80 over x plus 240 over x, which is just 320 over x. So we're left with 3x squared plus 320 over x is equal to a. And we showed the equation above, so P is 3 and Q is 320. Part B, we need to use calculus to find the value of x for which a has a stationary value, giving our answer to 3 significant figures. So in this case, a is like the function, so a is the f of x, and the stationary point is given when the dy dx of an equation is equal to 0. So we'll set the derivative of this equation here to be 0 in order to find the stationary value of a. So first we need to find the dy dx value of 3x squared plus 320 over x, which is, how do we find that? We multiply the power by the number in front of the x, which is, so it becomes 6x, and the power is minus 1, plus 320 over x is like 320 times x to the power of minus 1. So in this case, it is going to be minus 320x. Again, minus 1 power is minus 2. Now, we said before that the first derivative must be set to 0 in order for the value to be stationary. So then we set 6x to be equal to 320. Because we took it to the other side, the minus sign becomes a plus. And this is over x squared, we said before. Then we will multiply everything by x squared. This becomes 6x cubed is equal to 320. X cubed is equal to 320 divided by 6, which is 160 over 3. And x is equal to the cubic root of 160 over 3, which is 3.764. To 3 significant figures, it's 3.76. That is the x value for which a is stationary. In part C, we need to find the second derivative of the a, which is, so we found the first derivative to be 6x minus 320x to the power of minus 2. And we need to find the second derivative of that. So again, the second derivative, we do it just like the first derivative. So that becomes 6 minus 320 times minus 2 is plus 640. And we do minus 1 to the power, so it becomes x to the power of minus 3. When we input the x for 3.76, we get that the answer is 18. Why did we input the x? It's because we want to find the nature of the stationary point. And when you do the second derivative, you find the nature of the stationary point because if the answer is bigger than 0, like in this case, then it's a minimum point. But if the answer is smaller than 0, then it's a maximum point. In this case, because 18 is bigger than 0, we get a minimum point, and that is the nature of the value of x that we found. In question 4, we are given that in a particular geometric series, the sum of the first three terms is 70.2 and the sum to infinity is 75. And we need to find for this series the common ratio. So first we'll just write this a bit better. The sum of the first three terms in a geometric series is given by Sn equal to a times 1 minus r to the power of n over 1 minus r. If we substitute that, the sum we found to be 70.2, which is equal to a times 1 minus r, n in this case is 3, over 1 minus r. The sum to infinity, since in order for it to be a sum to infinity, r must be smaller than 1. So, and then we can just use this formula, this equation, where sum to infinity is equal to a over 1 minus r. Both are given in the formula sheet, so you will not have to memorize this. And then if we put the sum, which is 75, to be equal to a over 1 minus r. And in part A, we need to find the common ratio. So in order to find the common ratio, we need to find the constants. The common ratio is r, and we have two unknown constants, a and r, so we must get rid of one. Well, it seems that it's easier to remove 1 minus r here. So we'll go ahead and leave 1 minus r alone by cross multiplying it here. And that will leave us with 1 minus r is equal to a over 75. Now that we found that, we can put this instead of 1 minus r here in this equation. So if we go ahead and do that, that will be 70.2 is equal to a times 1 minus r cubed over, instead of 1 minus r, we'll put a over 75. Now, these two cancel out, and these two will be multiplied. So 70.2 is equal to 75 times 1 minus r cubed. If we leave 1 minus r cubed by itself, we will divide everything by 75, and that will give us an answer of 0.936 is equal to 1 minus r cubed. If we make r cubed positive, we'll get r cubed is equal to 0.064. And r is just the cubic root of this. So if we just find the cubic root of that, we get that r is equal to 2/5. Now that we found r, which is the common ratio, we can go to part B and find the first term. This is much easier now. All we gotta do is substitute the r into this equation here. And we get 75 is equal to a over 1 minus r, which is 3/5. And we have to take all that to the other side and leave a to b by itself. So we get 75 is times 3/5 is equal to 45. So a is equal to 45. Question 5. We are given a function f of x equals to 3x cubed plus ax squared minus 10x plus b. A and b are constants. And given that 3x minus 4 is a factor of f of x, we need to show that 16a plus 9b is equal to 56. That is simple. We need to show, since it's a factor, it leaves us with a remainder of 0 when we put the x to be this. So we can say that 3x cubed plus ax squared minus 10x plus b will be equal to 0. So surely this here means that f of 4 over 3 is equal to 0. If we just substitute x for 4 over 3, so we do 3 times 4 over 3 cubed plus 4 over 3 squared a minus 10 times 4 over 3 plus b is equal to 0. And if we calculate that, we get 64 over 9 plus 16 over 9 a minus 40 over 3 plus b is equal to 0. If we multiply everything by 9 to get rid of the denominators here, we get 64 plus 16a minus 40 times 40 over 3 times 9 is 40 times 3, which is 120, plus 9b is equal to 0. Taking what we need to show, we need to show that 16a plus 9b is equal to 56. So already the a and the b values are positive, so we just have to take the numbers to the other side, leaving us with 16a plus 9b is equal to 120 minus 64, which is 56. Now we are told that when f of x is divided by x minus 2, the remainder is b. So again, shortly that means that f function of 2 is equal to b. So if we substitute x for 2 in the above equation, we'll get 3 times 2 cubed plus 2 squared a minus 10 times 2 plus b is equal to b. Solving this, we get 24 plus 4a minus 20 plus b. If we take this b to this side, we get minus b, so plus b minus b is just 0, leaving us with equal to 0. So 4a plus 4 is equal to 0. 4a is equal to minus 4. So a is equal to minus 1. Substituting a into this equation to find b, we get 16 times minus 1 plus 9b is equal to 56. So minus 16, taking that to the other side, we get 9b is equal to 72. 56 plus 16 is 72. So b is equal to 8. In part C, it says, hence using algebra... oh my god. In part C, it says, hence using algebra, fully factorize f of x. Well, we already know that one factor is 3x minus 4. So we will just do long division to find that. But first, we will finally write the full equation correctly, putting in the value that we found for a and the value that we found for b. So it becomes 3x cubed plus, minus 1a minus 1x squared minus 10x plus 8. We'll go ahead and do long division. So we said before that 3x minus 4 is already a factor. So if we divide this by 3x minus 4, we should get another factor. 3x minus 4, this goes x squared times in this. So 3x cubed minus 4x squared minus all that. Minus x squared minus 4x squared. So that's minus plus 4x squared. That leaves us with 3x squared minus 10x. That's plus x. So minus 3x squared minus 4x. That's plus 4x again. So minus 10x plus 4x. We're left with minus 6x plus 8. And this goes minus 2 times. So we're left with minus 6x minus times -2 times -4 is -8, is +8, sorry. And we take that away and we're left with 0, so this is a perfect factor. So 3x minus 4 times x squared plus x minus 2 is the factorized thing, and we need to factorize this fully. So x squared plus x minus 2 factorized fully gives us x. This is simple to factorize. We just see that the x value is, when x is to the power of 1, it's positive, but the number is negative. So we know that one value must be negative, and there are only two factors of 2, so it's 1 and 2. One must be negative, one must be positive, but since this value of x is positive, we know that the bigger value must be positive and the smaller value must be negative. So we're left with x is equal to -2 and x is equal to 1. Those are also factors, and factorizing that fully, we get 3x minus 4, x plus 2, and x minus 1. That is the fully factorized equation. In question 6, we are shown a diagram with a circle, a diameter, and a chord. It says that the point A has coordinates -1, 2, and the point B has coordinates 11, 6. Both lie on a circle with a center P, and point M is the midpoint of AB. Given that line L passes through M and P, as shown in figure 2, we need to find an equation for L, giving our answer in the form of y equals to mx plus c, where M and C are constants. So immediately we know that these two lines are perpendicular, because when a diameter passes through the midpoint of a chord, that means that the chord is perpendicular to the diameter. First of all, we're going to find M, the coordinates of M. Since M is the midpoint of the line AB, we can find that easily, because the equation to find the midpoint of a line, we need to do to find the x coordinate, we need to do the x of the one end plus the x of another end over 2. That will be the x coordinate. And to find the y coordinate, we need to do the same thing for the y. Therefore, if we put in the coordinates of A and B there, for the x coordinate of M, we will do 11 plus -1 over 2. That is 10 over 2, which is 5. And for y, we will do 6 plus 2 over 2, which is 4. Therefore, the coordinates of the midpoint of M are 5. The coordinates of M are 5, 4. Then, to find the equation of L, we need to know the gradient. How we'll find the gradient? We will find the gradient of the line AB, and the gradient of perpendicular lines are the inverse, this inverse sign and the reverse denominator and numerator. How we'll find the gradient of AB? Well, to find the gradient of 2 points, of a line that has 2 points, we do the y value of 1 point minus the y value of another point divided by the x value of the same first coordinate minus the x value of the other coordinate, and that will give us the M. In this case, we will do 6 minus 2 over 11 minus -1, which gives us 4 over 12, which is the same as 1 over 3. We said that that's the equation, that's the gradient of the line AB. the gradient of the line L is just, as we said before, inverse sine. So this was positive, now we make it negative, and we reverse the denominator and numerator. So in this case it's going to be 3 over 1, so just 3. Now that we found the gradient and we have a known point, we can find the y-intercept, the c, easily. We'll just do y equals to minus 3x plus c, and we put in the coordinates of one point that we know is on that line. So in this case we'll do 4 equals to minus 3 times 5 plus c. This is equal to 19 is equal to c. So if we go ahead and put that in the equation, we get y equals to minus 3x plus 19. In part B, it says that given that P has coordinates 7k, where k is a constant, we need to find the value of k. We're just going to substitute, instead of x, we're going to put 7, and we're going to find the y value. We're going to do y equals to minus 3 times 7 plus 19. Y equals to minus 21 plus 19. Y equals to minus 2. K equals to minus 2. In part C, we need to find an equation for the circle. To find an equation for the circle, since we know the center, which we found to be 7 minus 2, the equation of a circle goes x minus the x coordinate of the center, so we're going to say that to be a, all to the squared, plus the y minus the y value of the center, we're going to say that to be b, all to the squared, equals to the radius squared. Since we know the center, we already have the equation half completed. So since the equation that we said is x minus the x coordinate of the center, which we found to be 7, so it's going to be x minus 7 all to the squared, plus y minus the y coordinate of the center, which we found to be minus 2, so that's just plus 2. And we need to find the radius and then square it. How we'll find the radius? Well, we will just find the length of this line here, because since this is a point on the circle and this is the center, this is just the radius. How we'll find the length of that line? Well, to find the length of the distance between 2 points, we do the y coordinate of one minus the y coordinate of another, all to the square, plus the x coordinate of one minus the x coordinate of the other squared, and all of that the square root of that. So we'll take the y1 and the x1 to be the center, and the y2, x2 to be the point A. Point A has coordinates minus 1, 2, and P has coordinates 7, minus 2. So in this case, we'll do the equation now. Square root of all that, so minus 2, because minus 2 minus the other value, so we get minus 2, all to the squared, plus the x value, so 7 minus 1, which is just going to be 8, and all that to the squared again. So this is 4 squared, which is 16, plus 8 squared, which is 64. So we find that the radius is 16 plus 64, that is root of 80. That is the radius. And since for the equation to be complete, we need to get the radius squared, that will just be 80. So the full equation will be x minus 7 squared plus y plus 2 squared is equal to 80. In question 7, we are given a table that shows the values of x and y, where y is equal to the log base 10 of x plus 5 for x values between -1 and 4. And using the trapezium rule, we need, with all the values of y in the given table, we need to show that the integration of log base 10 x plus 5 is equal to log base 10 k, and we need to find the integer of k. So the trapezium rule will always be given. It goes like this: 1 over 2h times h, where h is the height, so it's the difference between these points, times by the first y value plus the last y value, plus 2 times all the in-between values. So in this case, it's going to be 4 values, so y1 plus y2 plus y3 plus y4. That is the trapezium rule. If we put all the values inside, we will get a solution to that. So 1 over 2, we said the height is the difference here, which is 1 in this case. So we don't even have to write that, just leave it with 1 over 2. Times the first y value, log base 10, 4, plus the last y value, log base 10 times 9, plus 2 times of all the in-between values, so log base 10 5, plus log base 10 6, plus log base 10 7, plus log base 10 8. Now to solve this, we need to know an identity of logs, which is log of b of x base a plus log of y base a is equal to log of x times y base a. So now that we know that, we can solve that pretty easily. That leaves us with 1/2. We add all this up. So log base 10 4 plus log base 10 9 is the same as log base 10 36 plus 2 times log of plus 2 times all this, which will be log of base 10 5 times 6 times 7 times 8, which will give us an answer of log base 10 1680. Now another identity that we need to know is that a times of log b base x is the same as log base x b to the power of a. So we can go ahead and finish this off. Half of log 10 base 10 36 plus log base 10 1680 to the power of 2 gives us log of 2,822,400 base 10. If we also add that, multiply those two, we get half of log base 10 100,606,400. And to get rid of that half, we do the same thing as before. That is the same as this to the power of a half. Which is, we finally get log base 10 of 10,080. In part II, we need to find the value of a such that 2 log base 5 of 5 minus 8 minus log base 5 of a plus 25 is equal to 1. and we need to find the value of a. First, we'll get rid of the 2 in front of the log base 5 minus a, and make it as such. Expand that bracket, and 2, when you have a log base 5 minus something, log base 5 of something minus log base 5 of something else, it's the same as this divided by this. So we'll just do that. When you have log of x base a is equal to b, that's the same as a to the power of b is equal to x. So that's how we can get rid of the logs. 5 to the power of 1 will be equal to 25 minus 10a plus a squared over a plus 25. Taking this to the other side, we'll get 5a plus 125 equals to 25 minus 10a plus a squared. And taking all that to one side, we're left with a squared minus 15a minus 100 is equal to 0. And we can just go ahead and factorize that to find the values of a. That's simple factorization. So a is equal to 20 and a is equal to minus 5. In this case, a equals to 20 will be rejected, because if we put 20 into this bracket here, we would get a negative value for this here, and we cannot have a negative or 0 be in one of the brackets here. So the final answer is a is equal to minus 5. In question 8, it says that a student states if x and y are irrational numbers, then xy is also irrational. And we need to show by a counterexample that this statement is not always true. Now, an irrational number is one that has an infinite amount of decimals, or it's a never-ending number. For example, root 2 or pi is irrational. Now, what we could do to do this, it may seem difficult to determine what values to pick, but we can pick values that when multiplied, we make sure that the irrational numbers are cancelled out. For example, if we get 2 over pi for one value and pi over 4 for another value, this ensures that when we multiply these together, they will cancel out. So we just get these two values, multiply them together, this and this cancels out, this can be simplified to this, and we're left with 1/2. So we just say, hence, proved false. In part II, we need to prove using algebra that for all odd integers n, the value of the expression n cubed plus 3n plus 2 is always even, but never a multiple of 4. So how we'll do this? We need to show that for all odd integers of n, so an integer must always be odd when it is multiplied by 2 and you add 1. So for example, a, when you multiply it by 2, it must be even, so when you add 1, it must be odd. So we can go ahead and define n as 2a plus 1. And then we put, instead of instead of n, we put 2a plus 1. And we expand that and we will probably be left with something which is a multiple of 4. Expanding that, we get 4a squared plus 4a plus 1 times 2a plus 1 plus 6a plus 3 plus 2. Expanding that even more, we get 8a cubed plus 4a squared plus 8a squared plus 4a plus 2a plus 1 plus 6a plus 3 plus 2. If we go ahead and add up all the like terms, we're left with 8a cubed plus 12a squared plus 12a plus 1 plus 3 plus 2, which leaves us with plus 6. So we need to show that it is always even but never a multiple of 4. So if we try and factorize the 4 outside, we'll be left with 2a cubed plus 3a squared plus 3a plus 1, but we'll also have a plus 2 remainder here. So that means that it is not divisible by 4. However, all this can be factorized by 2, so it is divisible by 2, and an even number is a number that is divisible by 2. Therefore, when divided by 4, it will leave a remainder of 2, but it will always be even. In question 9, we are given a graph. It shows a sketch of a part of the curve with equation y equals to 9x squared times by 5 minus root of x all over 5. The curve has a turning point at the point M here, as shown in figure 3, and we need to use calculus to find the coordinates of M. So a turning point can be found when you set the first derivative to be equal to 0. However, before differentiating, let's simplify this equation a bit better. So that'll be 9x squared minus 9x 5 over 2 divided by 5. Differentiating that, we'll get 18x. Now to differentiate that, how we differentiate, we do the power times by the number in front, so 9 times 2 in this case, and we do minus 1 to the power, so it'll be just x, so 1, minus 9 over 5 times 5 over 2 is 9 over 2, x minus 1 to the power, we get 3 over 2. Setting that to be equal to 0 and solving for x, we will get the value of x for the turning point, the x coordinate of the turning point. Now we leave x to be alone on the other side. And we get a value of x to be 16. But we found the x coordinate. Now we also need to find the y coordinate. We'll find the y coordinate easily. We just put 16 into this equation here. So we get y equals to 9 times 16 squared times 5 minus root of 16 all over 5. We get the value for y to be 460.8. So the coordinates of M are 16, 460.8. In part B, it says that the curve crosses the x-axis at the point P as shown in figure 3, and we need to use algebra to find the x-coordinate of P. So since it crosses the x-axis, we know that the y value is 0. So we just put that y value, substitute y for 0 in this equation here, and we should find a value of x. Taking the 5 to the other side, we're left with 9x squared times 5 minus root x. Expanding that bracket, we get 45x squared minus 9x 5 over 2. Taking the minus 9x to the positive side, we get 9x to the power of 5 over 2. Leaving the x alone, we get 45 over 9 is equal to x to the power of 5 over 2 over x to the power of 2. So we get 5 is equal to x to the power of 1/2. So we get that x is equal to 25. In part C, it says the finite region R, shown shaded in figure 3, is bounded by the curve, the line through M parallel to the x-axis, and the line through P parallel to the y-axis. And we need to use algebraic integration to find the area of R, giving our answer to 1 decimal place. So in order to find the area or underneath a line, we need to use integration. So when you integrate the equation of a curve and put in the values, the bigger value that you want and the smaller value that you want, and you take those two away, you will find the area underneath the graph. However, in this case, we do not want this whole thing here. We only want this small thing here. So we need to find a way to get only that here. So what we will do is we'll find the integration, we'll find the area of this whole thing here and take away this small part here. How we'll do that? We will integrate the equation of the curve with the and put in the values of that we found here and the value of m here. If we go ahead and do that to make it a bit more clear, first we said that we'll find the area of the whole square here. So how we'll do that? We need the x-coordinate of m, which we found earlier to be 16, and the x-coordinate of p, which we found to be 25. So the distance between this and this is 9. And we need also the y-coordinate of m, because we already know that this is at y equal to 0. We found the y-coordinate to be 460.8. So if we just do 460.8 times 9, we'll find the area of the total rectangle there. That gives us an answer of 4,147.2. Now to do the second part, we need to integrate this equation here. And with the boundaries of the x-coordinate of p, which we found to be 25, and the x-coordinate of m, which we found to be 16. We have to put the equation in here. and we need to integrate that. So how we integrate? We add 1 to the power and we divide the number in front of the x with the new power. So that will become x cubed, and 9 over 3 will become 3. We go ahead and do the same thing for the other. So it becomes 7 or x to the power of 7 over 2. And we divide 9 over 5 by 7 over 2. And we're left with 18 over 35. Now we just have to put in these values inside and we'll find an answer for that area. And if we take away these two values, we're left with an answer of 2834.5. And now we just need to take away the previous value to do the previous value minus this value that we found now to find the value of the area underneath the graph, which is 1312.7. Finally, question 10, it says that we need to show that cos theta times 3 tan theta plus 2 over tan theta is the same as sine theta plus 2 over sine theta. So since we need to show that it is the same as that, we cannot take one value over to the other side. So to show the left hand side to be the right hand side, I'm gonna first make the tan theta be sine theta over cos theta instead. This is equal to now I'll expand the bracket and multiply everything by cos theta. This and this will cancel out, so it will leave us with 3 sine theta plus 2 cos squared theta over sine theta. One identity that we'll need to know for this is that cos squared theta plus sine squared theta is equal to 1. So cos squared theta will be equal to 1 minus sine squared theta. If we put 1 minus sine squared theta instead of cos squared theta, let's go ahead and do that. We will be left with 2, 1 minus sine squared theta all over sine theta. Expanding that bracket, we'll get 2 minus 2 sine squared theta. And if we separate these two, like so, we can simplify this and get 3 sine theta. This will be cancelled out and it'll leave us with minus 2 sine theta plus 2 over sine theta. And now adding up and taking away all the like terms, we're left with sine theta plus 2 over sine theta, which we needed to show, hence showed. In part B, it says, hence solve for when 0 smaller than x smaller than 2 pi, the equation of cos x times 3 tan x plus 2 over tan x is equal to 4 sin x minus 5. So we showed earlier that this is equal to this. So if we set that to be equal to 4 sin x minus 5, but in this case all this is x, and we multiply everything by sin x because we do not like this denominator here. We get sine squared x plus 2 equal to 4 sine squared x minus 5 sine x. Taking everything to one side, we're left with 3 sine squared x minus 5 sine x minus 2 is equal to 0. This is a hidden quadratic. We can replace sine x with a. So we're left with 3a squared minus 5a minus 2 is equal to 0. This is an easy one to factorize. We're left with minus 1 here, plus 1 here, and minus 2 there. So a is minus 1/3 and a is 2. But on the sine graph, the y-axis cannot go above 2. So this is wrong, so rejected. So only left with sine x is equal to minus 1/3. If we go ahead and find the first value of x, we do shift sine minus 1/3. Remember to have your calculator in radians. That gives us minus 0.3398. And remember, we have a boundary which goes like this. It's a good idea to write down the value of pi in order to have something to compare the values with. So this is the value of 2 pi. Now this is obviously rejected, but we can find the other values using the two identities that sine has, which goes like this: 2 pi k plus theta, 2 pi k plus pi minus theta. You can use this in order to find the other values of x. K can be any constant from minus 1, 0, minus 1, 0, 1, 2, etc. Anything that falls within this range here. So if we set x to be also equal to 2 pi k plus theta, we can try when the value of k is equal to 1. So when the value of k is equal to 1, we're left with 2 pi plus theta. Theta is minus 0.3398. So we're left with the value of x to be 5.943. That value falls within this range, so that value is accepted. Now we can go ahead and use this one here. So we get x equal to 2 pi k plus pi minus theta. We can try when k is equal to 0, which leaves us with just pi minus theta. So that is 3.48. We need to show our values to three significant figures. These are the only two values, so we can just go ahead and put those values. Remember, to three significant figures, so this is to three significant figures. and 3.48. Those are the two values for x. That was the January 2025 paper solved. It was a very recent paper, so it's important to try and solve this paper. If you have any other papers that you would like me to solve, please tell me in the comments. And if you have any questions for this paper, please let me know. Thank you.